Welcome Algebra 2 students. We're going to go over the 2-3 triads for part 1 today. So, in our first example, we're asked to factor this expression x squared minus 9. This is a special type. We call it a difference of squares because both of these terms are perfect squares. X squared is a perfect square, 9 is a perfect square. So for this type, what I want to do is take the square root of each term. Square root of x squared is x. The square root of 9 is 3. For one quantity, it becomes a sum, and one quantity is a difference. And remember, we can check this by multiplying it back out. X times x is x squared. The inners give us a positive 3x. The outers give us a minus 3x. So they cancel each other out. That's why we don't have a middle term. And then the plus 3 times the negative 3 gives us the negative 9. So in general, if you have a squared minus b squared, that would be a plus b times a minus b. And these two quantities can be in either order. It could be a minus b, excuse me, times a plus b. It doesn't matter which quantity comes first. Example B. So this is the type where we want to multiply the 3 and the 2. And now we're looking for factors of 6 that will give us negative 7 when we add them together. So I'm going to rewrite this expression using those factors of 6. So I'm going to write it out as minus 6x minus x. So again, what I've done here is I've rewritten the minus 7x as minus 6x minus 1. And that minus 6 and negative, or minus 1x. The negative 6 and negative 1 came from factors of 6 that would add up to negative 7. Now I can use my method of factoring by grouping to continue on. So I'm going to group the first two terms, and the GCF of the first two terms is 3x. I'm left with x minus 2. And then for the last two terms, I have minus x plus 2. Remember, I want these quantities to be the same. So I need to change the signs, which means pull out a negative 1. And that will give me a positive x minus 2. So I group the 3x with the minus 1. And the other quantity is the x minus 2. And remember, this can be checked as well by distributing and combining terms, and you should end up with the original expression. Okay, here's an additional example for example 1. Again, we have 6 when we multiply negative 3 times 2, and this time I want to get factors of 6 that'll add up to 5x. So let me rewrite this. That would be 3 and 2, so it's negative 3x squared plus 3x plus 2x minus 2. So again, I've rewritten that 5x using factors of 6. When I group these terms, I can pull out, let's pull out the negative. Pull out a negative 3x. So that leaves us with x minus 1. Okay, from these two terms, I can pull out the 2. And that'll leave me with x minus 1, which is exactly what I need, right? So I group these terms together. So that would be negative 3x plus 2 times x minus 1. Now, sometimes when you check an answer like this, you're not going to see the negative inside the parentheses. So that could be factored out. If you pull out a negative, think of it as a negative 1, but remember, we don't write the 1 there. And all I have to do is change the signs of this quantity and this quantity only. So it becomes 3x minus 2. I don't want to change the signs in both quantities because that would be like pulling out two negative 1s. So only one quantity changes sign. And again, if I redistribute this, I'd have 3x times x my inners are x squared, minus 2x, outers are minus 3x, and then plus 2. So I have 3x squared minus 5x plus 2, and then when I distribute the negative, I'll go right back to the original expression. So this part is just a check. And I only did that so that you could see that the negative, pulling out that negative, does work. So this is probably the best way to leave your answer, and that's probably what you'd see in an answer key or in the back of the book if you're checking your solutions. Another option, just so you know, would be to rearrange these two terms. So you might see written as 2 minus 3x, and then times x minus 1. And that would be okay too. When you redistribute, you're going to get that same expression back. Okay, on to example 2. So here the graph shows the function y equals x squared minus 9x plus 20. Identify the zeros of the function. So remember, the zeros is another word for x-intercepts. So I have one here at 4, and I have one here at 5. So how do the zeros relate to the factors of x squared minus 9x plus 20? So if I were to factor this, and I'm looking for factors of 20, that will add up to negative 9. So that's going to be negative 4 and negative 5. Now, I set that equal to 0, right? Because these are the zeros of the function, meaning that this is where y values are equal to 0, right? This is the point 4, 0, and 5, 0. So if I set my factors equal to 0 and solve from this quantity, I get a positive 4. And from the second quantity, I get a positive 5. And there you go. You can see the connection between the actual intercepts and the solutions and the factors. So keep this in mind for the future. When you're given the intercepts, you can work in the reverse and come up with the factors. So it's x minus that 0 to get the factor. Okay, example 3. Now we're going to solve by factoring. So remember, when we're solving, we want to get every term on the same side and have the equation set equal to 0. Remember, that's called a zero product property. So it only works when you have your equation set equal to 0. If I have an equation set equal to some other number, I can't factor that and solve. I have to get all terms to one side and then factor. Okay, so I'm looking for factors of negative 20 that will give me a positive 8. So that's going to be 10 and 2. So I want the 10 to be positive, and I want the 2 to be negative. Right, that gives me a positive 10 minus 2, which gives me the positive 8x. When I set each of these factors equal to 0, x plus 10 equal to 0 gives me x equal to negative 10, and x minus 2 equal to 0 gives me a positive 2. So remember, your solutions are always the opposite of the sign that you see within the quantity. Okay, so in other words, if I have factors of x minus a and x plus b, if it's a minus a, then one of my solutions is a, and if it's a plus b, then one of my solutions is negative b. Okay, I like keeping the leading term positive. So rather than moving this one term over to this side and making it negative, I'm going to move both of these terms over and subtract those. So I have 2x squared minus 3x minus 2. So when I multiply these, I have a negative 4. So I'm going to rewrite that middle term using 4 and 1. So it's 2x squared minus 4x plus x minus 2. So again, I use the factors of negative 4 and 1 to rewrite the expression, to rewrite that middle term. Negative 4x plus x gives me the minus 3x. Now I can use grouping. I'll pull out a 2x. And here I already have that quantity, but remember I have to pull out something. So in this case it has to be a 1. And again, it's important you write it there because that becomes part of the quantity with the 2x. So I have 2x plus 1 and x minus 2. If I set each of these quantities equal to 0, let me come up here. So I have 2x plus 1 equal to 0 and x minus 2 equal to 0. So remember, if this product equals 0, that's what the whole zero product property is about. If this product equals 0, either of these quantities can equal 0. So I subtract 1, divide by 2, and I get negative 1/2. Over here, I get the opposite sign. So since it was x minus 2, I get a positive 2. And notice here, this was a 2x plus 1, so my answer in the end is negative. And it's this number divided by the coefficient of x. So 1 over 2. So there's definitely a pattern to these solutions. Hopefully you're picking up on the pattern already, but we'll be doing more examples. By the time we're through, you should really have these patterns down. So I hope you enjoyed this lesson and have a good day.